In the beginning of this unit, we talked about CPCTC and what it stood for. CPCTC stands for corresponding parts of congruent triangles are congruent. So when you're writing those letters, think what it means. Don't just say the letters as you are writing it down. You want to use CPCTC as a proof reason when you have already proved the triangles are congruent. Okay, when you have proven the triangle's congruent, that's when you'll use CPCTC. And you'll use it particularly when you want to prove a part of it. You want to prove another piece. Okay, so you want to prove more about the triangle. I'll show you what I mean. So let's look. Write the congruent statement, give the reason, proving the triangles are congruent, then make a list of the remaining parts. See, here's what happens. In the beginning, we said if all 6 pieces are congruent, then the triangle is congruent. And then we said, wait, we don't need all 6 pieces, we need 3 pieces. But y'all, after I've used 3 pieces to prove the triangles are congruent, I know that all 6 are congruent. So that's what CPCTC is useful for. So it says that DB is perpendicular to AC. So perpendicular means that they are at right angles. Okay, and then it also says that, so this is what I know because of that. It also says that D is the midpoint of AC. D is the midpoint of AC means that AD is congruent to DC. So that's what I know because of that. And then from there, I look at it and I go, okay, what else do I know? Now, there are several different directions you could go with this. I know that you could, particularly with isosceles triangles, but unless you're guided in that direction, don't go to isosceles triangles. There's usually an easier way to go. And in this case, I could go with BD is congruent to BD. So that's the other piece that I know. Now, there are lots of places that we would go, lots of things that we would say in the proof. So DB is perpendicular to AC, which means angle 3 and angle 4 are right angles. And angle 3 is congruent to angle 4 because right angles are congruent. AD is congruent to DC. BD is congruent to BD because of the reflexive property, which means then that ABD is congruent to CBD because of side angle side. Okay, this is not HL because I haven't said anything about AB and BC. So this is side angle side. Here's why this is important, y'all. Because now that I know that those two triangles are the same size, here's what it tells me. It means that angle A is congruent to angle C. So now that I know that the triangles are the same size, I know that all the corresponding parts of those congruent triangles also have to be congruent. So I can say that A is congruent to C. I can say that angle 1 is congruent to angle 2. Okay, so I can also say this right here. I can say 1 is congruent to 2. And then my third thing that I can say is I can say that AB is congruent to BC. So now I have all 3, right? I have all 3 sides labeled. I have all 3 angles labeled because corresponding parts like A and C, 1 and 2, AB and BC, of congruent triangles, these 2 triangles here, are congruent. That's what CPCTC is useful for. Okay, so I am telling you that AB is parallel to DC. So if that's the case, then I know that 3 is congruent to 1 because they're alternate interior angles. Then it says that AC is parallel to DB. So I use that same transversal. So now what that tells me is that 2 is congruent to 4 because of alternate interior angles. And I look and I go, what else do I know? Well, there's several things that I know, but the one that's going to be the most important to me is this one right here. AD is congruent to AD because of the reflexive property. So now I can say that the triangles are congruent. Look at the pieces I have. I have angle 2, I have angle 3, and I have that side of the triangle. So then I can say that ABD is congruent to triangle DCA by angle side angle. And now that I know that those two triangles are congruent, I know all of the remaining leftover parts have to be congruent too. So I know that C is congruent to B. I know that CD is congruent to AB. And I know that AC is congruent to BD. Okay, and so there are lots of things that then I can say about it from there, but corresponding parts, once the triangles are congruent by 3 parts, the other 3 parts have to have congruent pairs too. So let's look at what these look like as a proof. Notice the difference this time. In this one, notice that I'm asking for the parts. See, before, I was asking you to prove the triangles are congruent. Now I'm asking you for you to prove the pieces of the triangles are congruent. But I have to prove the triangles are congruent first. So I have to go through all the steps that we learned earlier in order to be able to prove these pieces. So let's start with what we have. We know that JN is congruent to LN. And we know that KN is congruent to MN. We always go over and mark it on our picture because it will help us to keep up with everything. So JN is congruent to LN, and KN is congruent to NM. So that's what we know. Okay, so I have a side congruent to a side, and I have a side congruent to a side. So I either need another side or I need an angle. There is no way for me to know anything about JK and LM other than it looks like it, which is never viable. But I can say that angle, I can see that angle 1, that happened to my pen right there. My second step, I can say that angle 1 is congruent to angle 2. Why can I say that? Because vertical angles are congruent. So I know that angle 1 is congruent to angle 2. So now I have 3 pieces of information. Let's make sure my pieces are in the right order. I have a side, and I have a side, and I have an angle. But the angle that I have is tucked right down in between the sides. And so now I can say that triangle JNK is congruent to triangle LNM. And that is because of side, angle, side. So now I have said these 2 triangles are exactly the same size. Based on these 3 pieces, the triangles are the same size. So then what that lets me do is it lets me prove that angle K is congruent to angle M because corresponding C parts, P, of congruent C triangles, T, are congruent. C. CPCTC, corresponding parts, J and K, or K and M, of congruent triangles, J and K and LM, N, I read that wrong, that should be an N, LMN are congruent triangles, are congruent. So I have said K is congruent to M, which is what I was trying to prove. Okay, corresponding parts, CPCTC, will never happen until you have said the triangles are congruent. You can't use corresponding parts of congruent triangles until you have said the triangles are congruent. Okay, let's look at this next one. So let's first look at what was given. BD bisects angle ABC. I know I'm going to need that in a minute. And angle A is congruent to angle C. So first thing we have is given. Remember, everything, the result of everything is going to be a side congruent to a side or an angle congruent to an angle. Always mark it on your picture so I know A is congruent to C. Now, I've got this statement. BD, that segment, BD, bisects angle ABC. So I have cut, BD has cut that angle in half. Y'all, anytime I cut angles in half, then angles are my result. So that tells me that angle 1 is congruent to angle 2, because that is the definition of angle bisector. Okay, so now I have that angle 1 is congruent to angle 2. So I have two angles that are marked. I need a third. I need something. I need a third piece. A third angle doesn't do me any good, so the third angle theorem isn't helpful. I need a side. You have to have a side. So if we look, the easiest one is BD is congruent to BD. And in fact, that is the only thing that we can say at this point. BD is congruent to BD. That is the reflexive property. Okay, and then 4. So now I know BD is congruent to BD. So let's look at the pieces that we have. I have an angle here. I have an angle, and I have a side. And I have one angle that's touching the side, but then the other angle is hanging out there at the end. So what that tells me is I can say that triangle ABD is congruent to triangle CBD because of angle, side. Now, that's not my goal, right? Here's my goal. My goal is to say that DB is the midpoint of AC. Well, before I can say DB is the midpoint of AC, I need congruent segments. Okay, so think about what you want. If you're looking at it, D is the midpoint of AC. What you need to happen is you need for AD to be congruent to DC. Well, I just said those two triangles are the same size. Well, since those triangles are the same size, that means all their pieces are the same size. So what I can say now is that AD is congruent to DC. Why? Because corresponding parts of congruent triangles are congruent. CPCTC. I just said the triangles are congruent. Now I'm talking about their corresponding parts, and they're congruent also. Now that's not all I wanted to say. What I wanted to prove is that D is the midpoint. Well, if AD is congruent to DC, that means that D is in the middle. So D is the midpoint of AC. Okay, D is the midpoint of AC because that's the definition of midpoint. Okay, MP, I'm just shortening midpoint. Okay, so I had to talk about the parts. I said the triangles are congruent, so I can talk about the parts. Now that I'm talking about the parts, then I can say that D must be in the middle. And D must be the midpoint because it is in the middle between those two congruent segments, because that's the definition of midpoint, is a point that splits the segment into two congruent pieces. I have two congruent pieces, therefore I have a midpoint. Okay, the last one for today. AB is congruent to DC. So AB is congruent to DC. I also noticed something else in my picture. We'll deal with that in just a second. So AB is congruent to DC. We don't always need everything, but we always want to double check. ADB is congruent to angle CBD, and that one is marked. ADB and CBD, those two are marked already. I know that because I said so. So I have a side congruent to a side. I have an angle congruent to an angle. I need something else. In this case, you could go one of two directions, but I do recommend going with your easiest, most evident piece of information, and that is well, let's go with it, and let me show you. I recommend that you go with your easiest piece of information, but then I'm going to show you something. So we're going to go ahead and go with it. DB is congruent to DB, because I want you to see sometimes it doesn't work the first time. DB is congruent to DB because of the reflexive property. Okay, so here's what we know. Now look at what you've got. You've got this side is congruent to, it has a matching side. The reflexive property gives that a matching side, and then we have our angle. So hopefully you see the problem. Look, I have side-side angle. So while I do have 3 parts, I don't have 3 parts in the right direction. And this is not a right triangle. So I cannot prove that the triangles are congruent yet. So I have an extra piece of information, but I'm going to leave it there. It doesn't hurt. It is true. It's just not technically helpful. But it was a part of my thought process, so I'm going to go with it. Now, I did mention in the beginning, notice that these lines are parallel. So if I highlight those parallel lines and connect them together with a transversal, what I notice is that angle ABD is congruent to CDB. Because if lines are parallel, which they were marked that they were, if lines are parallel, then alternate interior angles are congruent. Okay, now when you look at your picture, now, yes, I have 2 sides with that angle, but now I have an angle in between those 2 sides. So now I can say that angle, that triangle ABD is congruent to triangle CDB because of side, angle, side. Side, side angle didn't work, so I had to go get something else. And I had something available, so I could. Now, I'm trying to prove that AD is congruent to BC. Well, here's AD, and here's BC. Well, that's easy enough, because since I just said those 2 triangles are the same size, I can say AD is congruent to BC because corresponding parts, those 2 pieces, AD and BC, those are corresponding parts of congruent triangles. I just said those 2 triangles are congruent. So I can say AB and BC are the same size because the triangles are the same size. But you have to prove that first.